So, dear student, we are going to be learn your new article that is known as the Ewald construction, and this article will study in now new technology you can use today, and that you can use a notepad for our lecture. So, see there is an incident and a reflected X-ray when there is an bragg reflection. So, in the angle between the incident ray and X-ray beams are separated by the angle, that is known as angular separation, by the 2 theta. So, angular separation is only 2 theta. So, should we remember that angular separation is an 2 theta. So, there is an 2 theta. So, angular separation between the incident ray and X reflected ray is, and we see there is an 2 theta. So, you can consider the reciprocal lattice point. So, this is an suppose a reciprocal lattice point. So, this is an already learned, so you can be see here is an lattice point as like this. So, here is also see there is a reciprocal lattice point. Okay. So, there are the so many reciprocal lattice points. Now we consider suppose there is an direction of the propagation of the wave such that incident wave vector means there is an incident X-ray. So, K is an your the incident K is an your the incident vector. So, K is an incident wave vector. So, K is an incident wave vector which is the terminant on the one of the lattice point, means your lattice incident wave vector is such that it terminate at one lattice point. Now, in this case, we suppose this is the incident wave vector which is an terminant at the point A. So, this is your point A. So, it should be remember there is an point A is your the so this is your lattice point where the wave vector will be terminate. And suppose there is an O is an origin. So, this is here O is your origin. O is your the origin of the your K vector. That is, the K vector is starting from O to the A. So, this is your the K vector. Now, construct the sphere in a reciprocal lattice such that its radius is OE. Means you can use it can be sphere, draw this sphere with the radius OA, that is an incident wave vector is now becomes the radius of the your sphere. Sphere. Now, O is your center of the sphere and K is your incident wave vector. So, O is also the radius of that wave vector, radius of the sphere. Now, suppose there is a magnitude of the K and K dash are equal. Magnitude of the K and K dash are the equal. Now, K is your incident vector. Now, K dash is your the K dash is your the reflected wave vector. Okay, it is a reflected wave vector. K dash is your reflected wave vector. You should remember your reflected wave vector. Now what happens, if the K and K dash, that is incident wave vector and reflected wave vector, are in equal, means you have to draw this K and K dash magnitude is the same, so it is an equal. Then tip of the reflected wave vector K dash is such that it lies on the surface of the sphere, because the magnitude is same as in the incident X-ray wave. So its a tip, means end point of the reflected wave vector is also represent on the surface of the sphere. So tip of the K dash, suppose this is your K dash, it is an represented. So tip of the point is also present on surface of sphere. So here is an at a point B. So here is your reflected wave will be the terminate, means this is your tip point of the wave vector. So it is lies on the surface of the sphere anywhere, but its a distance from the origin is a K dash. Now K dash must be equal to the K. Now suppose here is a B is an tip point of the your vector K dash, and A is an your tip point of the your incident wave vector. So if these two tip point of the incident and the reciprocal you have to connect it, so line which are the connected the tip of the two vector is known as a reciprocal attachment. Is known as a reciprocal attachment. So should we remember here, line connected between incident connected between the tip of, say it's the end point of tip of K and K dash is known as a reciprocal attachment. Is known as a reciprocal lattice vector. Reciprocal lattice vector is nothing but the line joining the two tip point. One tip point, that is your incident vector, another is a reflected wave vector. Now this is denoted by the G. So here is G. So AB is anyway the reciprocal lattice vector G. So from this equation, is here from this equation we can be write the equation K dash is equal to K plus G. K dash is equal to K plus G. See here, K dash, that is OB is equal to OA plus AB. So this is only our vector addition. So we got the OA plus AB is equal to OB. So K dash is equal to K plus G. Now we consider wave vector K dash is given by the above relation. So wave vector K dash given by this equation. So it is on qualify, it is on follow the Bragg's condition. Follow the Bragg's condition. Now we consider this figure. Now we consider this figure. Then we will see from this figure we can see there is a segment OE must be equal to the OB. So because it is the same as an radius of the your sphere, so OA must be equal to the OB. So it should be remember OA is equal to OB. So your triangle OAB is an your isosceles triangle. So your angle OAB is equal to angle OBE. Means angle A and angle B must be equal, and this is equal to the phi. See here, this angle is now phi. If this angle and this angle same, so it is also phi. Okay, so both are the angle phi. So this is an addition of the all angle of the triangle must be equal to the phi. So this is a 2 theta. This is a 2 theta. This is a phi. So we get the two theta plus phi plus phi, so is equal to 2 theta plus two phi. So 2 theta so we got the 2 theta is equal plus 2 phi. So we got two angle, that is a 2 theta plus 2 phi is equal to pi. If you take the common 2, so we got the theta plus phi is equal to pi by 2. So if you write the equation for phi, so you got pi by 2 minus theta. So we got the minus. So phi is equal to pi by 2 minus theta. Now angle between the positive direction of the K dash and your G dash. So here, see here, this is an angle. This is a positive. direction k dash. This is a j and your k, so positive. So this is an your angle. So this is an angle equal to the psi. So it is psi. Okay. So this is must be equal to psi is equal to pi minus phi. Psi is equal to these two angles, that is psi is equal to pi, because the phi plus psi is equal to pi. So we got so you required next page, we want next page, but where is the next page? Where is page? So we got your 2 theta. So psi is equal to pi minus phi, and phi is equal to pi by 2 phi is equal to pi by 2 minus theta. So pi minus pi by 2 plus theta is equal to pi by 2 plus theta. So we got the pi by 2 plus theta. Now it should be written here. It should be written here. Product of the k and g is equal to, so this is dot product kg cos psi. So should be got kg cos psi. Now psi is equal to pi by 2 plus theta. So we got kg cos pi by 2 plus theta. Now cos pi by 2 plus theta, so there will be change the angle cos pi by 2 plus theta, it is equal to minus sin theta. Cos pi by 2 plus theta is equal to so it will be the change, it is equal to minus sin theta. Actually cos pi by 2 plus theta is nothing but the minus sin theta. So k dot g is equal to kg sine theta. So there is a negative sign, so there is a minus kg sine theta. Now this equation must be used in your Bragg condition in a reciprocal lattice. So Bragg condition in a reciprocal lattice is the twice k dot g plus g square is equal to 0. Now this is a Bragg condition in a reciprocal lattice. So cos k dot g. So k dot g is nothing but the minus kg sin theta. So it can be root here. So using this equation, we got the minus twice kg sin theta plus g square is equal to 0. So it should be remember here g and there is a g, so one g will be cancelled. So if you take the common g, so it will cancel. Remaining term here twice k sin theta plus g is equal to 0. Twice k sin theta plus g is equal to 0. So we got the g is equal to twice k sin theta. Here. So we got the twice k sin theta is equal to g. So g is a reciprocal lattice. K is your incident wave vector. Sin theta, that is theta is an angle of incidence. So can we remember your reciprocal lattice vector? So is an always represented by this equation. G is equal to n into 2 pi upon d. So g is equal to n into 2 pi upon d. Now here n is the integer. N is an your integer. N is an your integer. So n is an your integer. Okay, n is an your integer. D is an your D is an your D is an your interplanar distance. It is the interplanar distance. In a direct lattice, मतलब interplanar distance है. In a direct lattice. Okay. So we got these interplanar distance in a direct lattice and n is an your integer. So by using this equation, this is an g also. So it should be used comparing the two equations. So we got n n 2 pi upon d is equal to your earlier equation, g is equal to twice k sin theta, twice k sin theta. So we got this equation, sin theta. So we got, this is the here n into 2 pi divided by d is equal to twice k sin theta. So what happens? 2 will be cancelled. 2 will be the cancel. So 2 will be the cancel here. 2 is a cancel. Okay. So there is a k is equal to 2 pi upon lambda. K is equal to 2 pi upon lambda. So we can be right here. We can write here n pi divided by d is equal to, so k is equal to 2 pi, k is equal to 2 pi upon lambda into sin theta. So we got this sin theta. So once again pi will be the cancel. So remaining term is the n upon d. N upon d is equal to 2 sin theta divided by lambda. So shifted this to this side and shifted this to this side. So we got n lambda is equal to twice d sin theta. So twice d sin theta is equal to n lambda is nothing but your regular Bragg's condition. Twice d sin theta is equal to n lambda. This is your Bragg's condition in your direct lattice. So this Bragg's condition in a reciprocal lattice is exactly similar to the Bragg's condition in direct lattice. This is an Ewald construction. Means Bragg's condition is not changed if you have to go to the reciprocal lattice or direct lattice by using the Ewald spherical construction. So should be remember here. So it should be remember here first, that is a figure. Figure is the most important. If you have to remember figure, then it is easy to be explain it. The basic concept you have to remember here. You have to use the incident wave vector and reflected wave vector both having the same magnitude, and it is starting from the origin O. So tip of the wave vector is always present on the surface of the sphere. When the two tip of your wave vector, that is incident reflected, connected, that is known as the reciprocal lattice vector. And then you have to, there is a relation between your angles and theta, phi and psi. And then you have to manipulate your mathematics. So we got the Ewald construction, that is your Bragg's condition, your reciprocal lattice, same as in the direct lattice. So this is an about your Ewald spherical construction. So you should be remember it. Thank you.